Welcome back to part 5 on composition of functions. We're actually going to move from just combining functions to the actual definition for composition. If we want to combine functions in the operation called composition, we need to take two functions and compose the functions, which is defined by f of g of x. You could also read this as f composed with g of x, or the composition of f and g, or we could also say composite of f and g. The domain of this function is the set of all real numbers x that are in the domain of g, and g of x is in the domain of f. So we have f composed with g being defined whenever g of x and f of g of x are defined. I think this will make more sense once we do an example. Let's graph f and g given below. The graph of f of x has domain from 0 to 8. And the graph of g of x has domain -9 to 4. Now let's look at our range values. The range for f of x is from -5 to 7. And the range for g of x is from -3 to 1. If we want to compose f with g of x, the composition means that any input into the function f of x needs to be in the domain of f of x. That means the outputs in g of x need to be in the domain of f of x, because f of x inputs are g of x outputs. Points along g of x, the first one's at -9, 1. The next obvious intersection is at -5, 0. And then there's another obvious intersection at -3, -3. And then if I look at this again, I have a -2, -1, and a 4, 0. Now remember, our outputs of g of x have to be in the domain of f of x. What that means is my range goes from -3 to 1. The only values that can be outputs in g that can go into the domain of f of x are when the outputs are greater than or equal to 0. And that only happens on the interval from -9 to -5. The rest of these outputs are negative except for 0. We have to throw out anything from -5 to 4 because they will not create something that is defined in the composition. So let's pick the values of x that will give us g of x that is defined. We know we can have a -9. That will give us a 1 as an output for g of x. We can have a -5. That will give us an output of 0 for g of x. If we wanted to find f of g of x, we would put 1 into the function. F of 1 gives me an output of -1. An input of 0 gives me an output of 3. So let's graph the composition of functions on this graph. Between -9 and -5, we will have a line. With an input of -9, we have an output of -1. That's our first point in the composition. At -5, we have an output of 3. So the composition is defined from -9 to -5, and it is a graph with a positive slope with rise 1, run 1. Now let's substitute 4. When we substitute 4 into our function g of x, we get an output of 0. F of 0 we have already found to be 3. And so a substitution of 4 into our function will give us a composition output of 3. So f of g of x's domain exists on the interval from -9 to -5, union 4. Because 4 can be a substitution into f of x, because we get a positive output. The rest of the values for g of x are negative range values. Therefore, we cannot substitute them into f of x.